This is the lesson 7.2 mini lesson. Today I'm going to teach you how to model and solve two-step equations using inverse operations, because in order to solve equations, you need to know how to isolate variables. So we're going to solve each equation and then we're going to verify. So I have the steps over here. So when we look at this, we are going to do the piece that is not attached to the x is the piece we're always getting rid of first. So I need to do the inverse of addition because this is adding 7. So I'm going to do the inverse, which is subtract 7 from both sides of my equals. So a lot of times I'm going to call these railroad tracks. So what you do to one side of the railroad tracks, you do to the other side of the railroad tracks. So now we have to remember all of our negative and positive rules. Over here, the negative 3x comes straight down. And here, positive 7 minus 7 would be 0. So that's gone. And over here, my signs are the same. I find the sum, and the larger absolute value is negative. So I get negative 15. Okay, that's step 1. Step 2 now, again, I'm trying to isolate for x. I want x alone, so I need to get rid of any numbers on the same side of the equals as the x. So now I need to get rid of this negative 3. And right now it means negative 3 times x. So I'm doing the inverse of multiplication. So I'm going to divide both sides by negative 3. So here's how I show division. Divide by negative 3, divide by negative 3. Negative divided by negative is positive 1x. We never need to write the 1. Negative divided by negative, positive 5. So I get x equals 5. Okay, so hopefully this is my solution. I want to verify it by substituting for the variable. So I'm going to go back in here and I'm going to rewrite and I'm going to plug in 5 in place of x. So I'm just rewriting this. Negative 3 means times 5 plus 7, and I'm hoping this is going to give me negative 8. I'm going to verify that. Now it says solve using order of operations. So on this side of the equals, we multiply first. A negative times a positive, negative 15 plus 7, hopefully is going to equal negative 8. Signs are different. I find the difference. Greater absolute value is negative. Negative 8 is equal to negative 8. So I know for certain that x is positive 5. Okay, let's try another one. So right now, the x is over here on the right side of my equals. So I want to isolate it. I want it alone. That means I need to get rid of both of these numbers. So remember, the first one I'm getting rid of is the one that is not stuck to the x. So I need to get rid of this. So the opposite of minus 3, I'm doing the inverse of subtraction. So I am going to add 3 to both sides. Plus 3 plus 3. Both sides of my railroad tracks are my equals. Negative plus a positive. Greater absolute value is negative. Signs are different. Find the difference. This would give me 0, so I can just bring down the 6x. Okay, step 2. This means 6 times x, so I do the inverse of multiplication. I divide both sides by 6. Divide by 6, divide by 6. Negative divided by a positive, negative 4. 6 divided by 6, 1x. So I want to verify and make sure that I'm correct. So I will verify by substituting negative 4 in place of x. So I'm rewriting negative 27, hopefully is going to equal negative 3 plus 6 times negative 4. Solve using order of operations. So I have to multiply first. So negative 3 comes down. A positive times a negative is negative 24. Now I'm going to continue to solve. Signs are the same. I find the sum. Greater absolute value is negative. So I do see that negative 27 equals negative 27. Because of this, then I know this is the correct answer. Okay, we have some that look a little bit different on the back. So again, it's still the same steps. I want to isolate for x. So I need to get rid of the numbers that are on the same side of the equals as x. So I need to get rid of both of these. But which one do I do first? The one that's not stuck to the x. This one's kind of stuck. So I'm getting rid of this. So what's the inverse of subtracting 4? I need to add 4 to both sides. Plus 4, plus 4. X sevenths comes down. Negative 4 plus 4 would be 0, so I don't have to write anything. Equals comes down. 0 plus 4 is 4. Okay, so now still I want to get x alone, so I need to get rid of this. This means divide by 7. So I do the inverse of division. I multiply both sides by 7. Here's how we do that. Think of this as a fraction. So when I multiply, I'm multiplying by 7 over 1. It doesn't look like a fraction over here, so I can just multiply by 7. So 4 times 7 is 28. Over here, remember when we're multiplying fractions, I can simplify. 7 goes in 7 once, 7 goes in 7 once. If I multiply across the top, I get 1x, and 1 times 1 is 1. So I get x equaling 28. Now again, I'm going to verify by substituting this back into the original. So I'm going to rewrite, instead of x, it's 28 divided by 7 minus 4 equals 0. I'm going to use order of operations. Divide first. 28 divided by 7 is 4. Bring down minus 4 and equals 0. And I'm hoping these are going to be equal. 4 minus 4, it is 0. So 0 equals 0. It worked. X is definitely 28. Okay, last example. I need to get rid of the two numbers on the same side of the equals as my x. So I need to get rid of the one that's not stuck to the x first. I'm getting rid of minus 5. So the inverse of subtraction is to add 5 to both sides of my equals. So again, right underneath, you're going to notice I line things up really neatly. Negative 11 plus 5, negative 6, equals comes down the middle. This would give me 0. I don't have to write it, but I'm bringing this down. X divided by negative 3. So again, I need x alone. So I need to get rid of this negative 3. It means divide. So I do the inverse of division. I'm going to multiply both sides by negative 3. So again, this is a fraction. So when I multiply by negative 3, I can make it look like a fraction. This side, it's not a fraction, so I'll just multiply by negative 3. Negative times negative, positive 18. Over here, I can simplify. Negative 3 goes in here once, negative 3 goes in here once, and I get x equaling 18. I want to verify by substituting for the variable. So right in here, I'm going to put the 18. So I'm rewriting negative 11, hopefully is going to be equal to negative 5 plus 18 divided by negative 3. Now I'm going to solve using order of operations. Negative 11 is hopefully equal to negative 5. Now here, a positive divided by a negative is a negative. So now I'm going to solve over here. Both are negative, so my answer is negative. Signs are the same, find the sum. So negative 11 equals negative 11. I know this is then the correct answer.